All right, so the first thing we're talking about are organic molecules, and our organic molecules have carbon and hydrogen. So in order to be considered organic, they have to have carbon and hydrogen. This is different from the organic you see in the grocery store. So organic foods, that's a different thing. Organic foods are foods that are produced without pesticides. When we're talking in chemistry and in science class, organic molecules means they have carbon and hydrogen, and they usually come from a living thing. We have a certain type of organic molecule. The title of this unit is macromolecule. A macromolecule is a big organic molecule. So it's a big molecule that has carbon and hydrogen that comes from a living thing. And the three main different classes of these macromolecules, so macro means big, it's the opposite of micro, are proteins, carbs, and fats. And fats are, or lipids. So macromolecules, or proteins, carbs, and lipids, are examples of organic molecules because they have carbon and hydrogen. They come from living things. So you guys were looking at formulas of these different molecules. So we're going to take a look at some formulas. And these are called chemical formulas. So chemical formulas show the number and types of atoms in a molecule. An example of a chemical or molecular formula would be H2O. You know H2O is water. Water is like the word, but H2O is the formula. Or glucose is C6H12O6. So that tells us we have 6 carbons and 12 hydrogens and 6 oxygens. So when you get done writing that, you can flip to the next page. We're going to learn that there are 2 different types or 2 different categories of carbohydrates. There's simple ones and complex ones. First, though, we're going to talk about what do carbohydrates have in common. So if we take a look at these pictures, what letters do carbohydrates all have? Yeah, C, H, and O in whatever order. So carbohydrates have C's, H's, and O's. Typically, these C's, H's, and O's have kind of a pattern. If we take a look at all of these formulas, what do all of these formulas have in common? What do we see? They have CHO, but what else? What about the numbers? What kind of patterns do we see? Which letters are the most of? H, okay. Roughly how many H's are there for every C? Yeah, there's about twice as many H's as there are C's. And what about the number of O's? That's close to what? Yeah, it's close to half of the H's as well. So we have about twice as many H's as there are C's and O's, okay? Not exactly, but about twice as many. So typically we say that's a 1 to 2 to 1 ratio. So write this down. CHO next to your CHO, 1 to 2 to 1 ratio, meaning there's twice as many roughly H's as there are C's and O's. So this is how we can identify a carbohydrate. So if we look at this next slide, again, we need to have about, not exactly, but about twice as many H's as C's and O's. In number 1, do we have twice as many H's as C's and O's? Yeah, so that's a carbohydrate. What about number 2? No, because we don't have enough O's. What about number 3? Yeah. Okay, what about number 4? Yeah. What about number 5? We're missing O's. All right, good. So we can tell which ones are carbohydrates. Now, we said these are macromolecules, so big molecules, which means they have to be made of littler parts. The littler parts that they're made of are monosaccharides. So they're made of these little hexagons. Mono means one, saccharide means sugar. So 1 sugar. Building block is a monosaccharide. So we connect a whole bunch of these together, then it makes what we call a big carbohydrate, a macromolecule. Now there's 2 different types of carbohydrates. We've got simple carbohydrates and we have complex carbohydrates. Examples of simple ones only have 1 or 2 building blocks. If they have 1 building block, we call them monosaccharide. Mono is 1. So label this on your diagram. If there are 2 hexagons, we call it a disaccharide. So 2 sugars. All right. So simple carbohydrates. What are simple carbohydrates found in? They are found in sugary and sweet foods. So sugary and sweet foods, things like donuts or cookies. So sugary, sweet foods. If you think about what sugary foods do, they give you a lot of energy right away. If you eat a whole bunch of candy, typically people are like, oh, you're really hyper. So they give us really quick energy. Now, this week, we're going to be testing different foods to see if they have simple carbohydrates in them. So the test that we're going to use, okay, is going to be something called Benedict's test. And it's named after this guy, Benedict, and it's a blue solution that we are going to add to the food, and then we're going to heat it up. And I'll show you what happens when we heat it up. I've got a little video clip that we can watch, but you'll do this. Tomorrow, if you want to bring in any foods to test, you can. So let's take a look at what happens here. So when we heat up this solution, take a peek at what happens. So it starts out blue. And what ends up happening here is it ends up turning colors if there are simple sugars present. Okay. So if there are simple sugars present, we end up getting that color change. And we can actually tell the color change will tell us how much sugar there is present. So if it's green, there's a little bit, orange, a medium amount, or red, there's a lot. So we're going to write this down here. So if the simple carbs are present, we have, it will be either green, orange, or red. If they're absent, it's going to be blue. So again, this is for simple carbohydrates, simple sugars here. We can also test for complex ones. Complex ones have lots of hexagons. They might even have way more hexagons connected together than this. And we call this a polysaccharide or starch. We know starch. Poly means many. Now, what are complex carbohydrates found in? They are found in things that are like starchy, bread, potatoes, rice. Plants store a lot of their starch underground in roots. And so you'll see a lot of roots up there. So like potatoes or carrots. And instead of quick energy, these are going to be used for storing our energy. So saving it for a little bit later or longer energy. Our test for starch that we already know is iodine. So we can take iodine and add it to that food and figure out if it has starch in it or not.
And the other is a starch solution.
If we add the
When a single drop of the iodine test solution
yellowish,
is added to
and if
each,
we add it to
the vial
starch,
on the left
we
turns
see
a
that it
yellow-orange
turns
color,
the solution
and the one
like
containing
purple or
starch
black,
turns a
depending on how
black-blue color.
concentrated it is. So if starch is present, we get it being purple or black, and if it's absent, it ends up being yellow or orange. So simple carbohydrates, complex carbohydrates. We will do some tests on some foods tomorrow. If you would like to bring in a food to test, you can. It can be anything.